Welcome to all. Engineering Mechanics, today is class number 72. We are in part 2. As I told, part 2 is equilibrium, types of loads and support reactions. Equilibrium already over, lecture number 1 to 19. But make a note, equilibrium is not over. Entire structural engineering equilibrium will come. But some basic concepts are over. Type of loads, this is the most powerful part. Those people who want to gain structural knowledge, this is number one. I will tell right up to now, number one concept. You have to thoroughly go through. Then, support reactions is from today's class, lecture number 31 for part 2. Now, each and every class, I will not tell this one. Next time I won't tell anything. I will just start. In the title you can see Engineering Mechanics class 73, part 2, lecture number 32. Title will be there. So because we can't afford to waste time each and every class to tell what is going on. Okay, now come to, now our heading is support reactions. See, main heading, support reactions. Support reactions. Make a note briefly. I am dictating. See, so many things I will start dictating now. You have to write it. Support reactions are the reacting forces or sometimes couples acting on the member or body which is supported by the support. Some support will be there. See, each and every structural member or any body for equilibrium, it requires some support. See, for example, I will take this pen. See, unknowingly, my fingers are supporting it now. Suppose I remove the finger, see, it will fall down. Tendency of the loads or forces acting on any member or any body is to displace it. There are two types of displacement. One is linear, see, meter, etc. Linear, see hand, linear or linear. Second is angular. Linear displacement is, unit will be say centimeter, millimeter, etc. Angular, radian, degrees, etc. So angular displacement is also called rotation, rotational effect. And linear displacement, you can tell translational effect. Write everything. Now, support reaction, when it will come? Before that, one important note is there. I will tell you that one. When support reaction will come? Whenever the displacement is either fully prevented or partially prevented. The prevented is required. It is not compulsory that fully prevented. Even partially prevented also will do. There will be reactions. I'll give simple example for you. Very simple example. Imagine you are going in the road and suddenly due to some problem, maybe you touched someone, etc. Someone is coming for fighting with you. See, that is action, effect of loads. Now, reaction from you. Suppose you keep quiet, tell sorry and go. You don't want to fight. Two reasons. One, maybe you are not that type to quarrel in the road. You are a dignified person and somewhat what you can call is well educated. You don't want to use foul languages and fight in the road. Cultured person. Okay, you just ignore and go. But partially you get little annoyed. So you start fight back. Fight back means what? You give some reaction. See, not fully, partially. You just, what way he is fighting with you, you don't fight that way, little lesser amount. 3, you are very rigid person. How much he fights, you will fight back same way. Severe fighting. So, reaction will come. See, suppose he will come and try to push you. You simply go away. Go. When he pushes you, he will come and push you. Okay, you walk as if you are not bothered. So, displacement is allowed. You are not yielding to him. Sorry, you are yielding to him. So, when you yield, displacement is allowed. No reaction. See, he will push you, you go. That's all. He also will keep quiet. But suppose he will push you, you partially prevent it. It will become angry. That is called partial. Some reaction is there. Or you fully get ready for fighting back. Full reaction. So there is no question of partial reaction, full reaction. That example I am giving. See, one is no reaction. Simply ignore. He will try to push you, you go. See, simple example. I will hold the pen here. Write everything. I will drop, lay the support. Tendency is to go for vertical displacement. Yes. Vertical displacement takes place. Nothing prevented. Therefore, no reaction. Or see, I will move the pen here now. See, I will move the pen here. You can see I am applying a force. Nothing is there to prevent displacement. When I apply the force, the pen is moving. See, yes, no reaction. Finally, I will come and touch the board. See here now. Now, if the force applied, this board will not allow you to move further. That is, earlier displacement allowed, no reaction. Now, displacement is prevented. Yes, when displacement is prevented, there is reaction from the support on you. Or, see, suppose I hold a pen here this way. I will put a pin type, see. I will explain later. I try to, see, finger is very tight. Some arrangement is there. I will try to pull this way. Yes, no. I am not allowing here. See, if you can see, you are giving a reaction. Or I will push this way. Still you can see reaction is there. See, but if you try to rotate, see, oh, these two fingers you hold this way. This is called hinged or pinned connection. See, no reaction because displacement allowed. Or furthermore, I will take support here. See, I will place a member this way. This is called simple support later. I will apply downward force. No, this is very firm. Displacement is not allowed. See, unknowingly, from the other hand, when you apply load this way, there will be a reaction. But I will apply load this way, force, see. No. Why? Displacement allowed. This is simple support. This all I will explain. Now, or you take a pen here, see. Fix here, this way. Fully fix here. Apply a horizontal force. No, it is not coming. So, there is a reaction. Apply a vertical force. Yes, there is no reaction. Apply a couple. See, the moment you apply a couple here, see here, what I will do? I will do this way. Oh, now, translation is prevented in both horizontally, vertically, and even rotation is prevented. So, now, there will be vertical reaction, horizontal reaction, and also reacting moment. This all I will explain. No. So, and as I told you, most important statement, reaction will come when displacement is either fully prevented or partially prevented. No reaction if displacement is allowed. I told, no reaction if displacement is allowed. I will give a small example for partial. Suppose imagine you got a beam, one simply supported beam here. Don't bother. Firmly face here. See this way. Apply a load. This will try to push it down. This support will not allow for moving. It will prevent it. Therefore, there will be reaction. Now, what I will do is, I will put a spring here. Spring here. When you apply a load, this support is rigid. This will try to come down. So, this point will come down. There will be some displacement, but the spring will get compressed, then the spring will give reaction. Even then reaction is there. But how much is reaction? Is it same as earlier? Yes. In the case of this beam, it is same as earlier. Maybe once it yielded, then it once again started resisting. So here, the spring will not change the reaction. Why you don't bother now? It all comes later. But remember, suppose there is a beam, one side fixed, other side you put a rigid support. You apply a load here, 10 kilonewton. See, this support is not moving. It will prevent the vertical displacement. So, it will give a reaction of, say, for example, 10 is there, partially here, say 4 kilonewton. Just imagine, reaction. 4 kilonewton is the reaction if the support is not, if there is no displacement here, means rigid, displacement prevented. Now, same beam, if you put a spring here, applied a 10 kilonewton load, somebody will tell, now the reaction will not be 4, it will be lesser. It may come, I don't know how much it is, say 2.8 kilonewton. Somebody may ask, last time you told spring, even if the spring is there, even if it got slightly displaced, same reaction came. But now, because of spring, reaction reduced. That is because that is statically determinate structure. This is statically indeterminate structure. For statically indeterminate structure, reaction depends upon displacement. Or this much is not required for you. I just told for those who got good structural knowledge. What happened is, reaction will come when displacement is either fully prevented or partially prevented. Partially prevented case will come when you go to structural analysis. Okay, now this is simple thing I told. Now, important note. That's all I am explaining for reaction. I am going to engineering mechanics part now. Because in engineering mechanics, you don't discuss much structural behavior. Now, very powerful note. Later, when we start strength of materials, when I start the subject, the first I will tell maybe continuously for 2 to 3 hours. 3 hours. Non-stop, I will give lot of important and very useful and powerful explanation. There, a term called section force will come. Section force like axial force, shear force, bending moment and twisting moment or torsional moment. At that time, the support reactions, 2 terms will come then. One of them is called action, other is called reaction, other term is equilibrium. Then equilibrium and section forces, comparison will be there, and what are do's and do nots will be there. What mistake you people are likely to make, I will highlight that one. I will tell everybody, don't make the mistake. Therefore, this time when I go to strength of materials, starting, I will explain each and every concept of support reaction and equilibrium once again. Then some of them are direction based, some are nature based. When you do equilibrium, you consider direction, right side, left side, upward, downward, clockwise, anti-clockwise. But when you do section forces, you don't consider direction, you consider nature, compression, tension, bending, sagging, shear, twisting, etc. This all I will explain. Therefore, right now, what I told is sufficient. You write a summary now here. support reaction will come or will be developed when displacement is either fully full I will not write, there will be support reaction or support reaction will be developed when displacement or displacements is or displacement or displacements is or fully or partially prevented. Very, very important. There should be some prevention. That is, either you fully fight back or partially fight back. If you fully fight back or partially fight back, if someone is scolding you, you fully scold him back, or you little lesser, you partially scold, that is reaction. If you keep quiet, if the displacement is fully allowed, then there will be no reaction. This much is sufficient for engineering mechanics now. But in the notes I will write much more. This all in the class I am dictating, you should write. Okay, now I will go a little more. Start. First consider reaction from surface or plane. This is required for friction chapter and for some particular questions you require. Structurally you don't require it, but I am covering engineering mechanics systematically. See, class. What I dictate in the class you have to write. Consider a body resting on a horizontal surface. Two cases are there, two simultaneous cases. This I will remove. This also I will remove. Consider a body or a block. Some weight is there. See, weight is acting vertically down. Okay. Resting on a horizontal surface. Time being horizontal surface. Okay. Now, the tendency of this weight is to go down. Surface is smooth, and here imagine surface is rough. Surface is rough. Now, irrespective of whether it is smooth surface or rough surface, see here, smooth surface or rough surface, see here, vertical displacement is not allowed. When the weight is acting down, this will try to go inside. So therefore, the surface will prevent it going down. So right here, class, I am writing here, class. Therefore, go back means don't go back. Right here, therefore, there will be a reaction here which is normal to the plane. There is a reaction here, normal to the plane. I will tell reaction R, which is perpendicular to the plane. Now, suppose you apply a horizontal force. See here. Now, this surface being smooth, when you apply horizontal force, this surface cannot balance it. Smooth surface. Smooth means what? No friction. It is no friction. You can write here. Smooth means no friction. Actually, this more will be discussed when I go to friction. There is friction. Okay. Now, see, for example, smooth surface I want. This is somewhat smooth, see, very smooth. I will place a weight here, apply a force this way. See, you can see it is moving. Therefore, right here, this time, along surface, this way, no reaction. This way, or along surface, no reaction, because it will move. Here, if surface is rough, very rough, when you apply the force, suppose you take a rough surface and apply weight. If the weight is applied force is smaller, there will be frictional reaction. See, this is frictional force. See, this is reaction in the form of resisting frictional force developed here. Now, by chance, you write all the statement and go back and first you put the block, write all the statement, then write one more surface sketch and enter this one. Then write here. Suppose you apply heavy force, then it will overcome friction. This will start moving. Even if it start moving, friction force will be there, because why? It cannot move like a smooth surface. When surface is rough, little displacement is prevented. See, vehicles, little displacement is prevented. Therefore, even if it is moving, then also it cannot move freely as if it is moving on a smooth surface. So, compared to movement on a smooth surface, movement is reduced, so partially prevented, there will be friction. Or now consider inclined plane. See, just to understand, like right now, just to understand. Inclined plane. Imagine a plane here. One, smooth plane. Smooth plane means no friction. Rough plane means friction is there. When you apply load here, this will try to see, it may try to come down. So it is free to move here. But remember, it will press here, there will be a normal reaction. See, smooth surface can give only normal reaction. And along the surface, reaction will come if roughness is there. But here, if rough surface is there, there will be normal reaction R, and also when you try to slide this way, there will be frictional force FF. Anyway, these all we will discuss, everything we will discuss when you go to friction. So right now, not required. So what I want now? Now, right now I want to, one information for you. If any body or a block or a member is resting on a surface, then there will be a reaction perpendicular or normal to the surface, and along surface frictional reaction will come if surface is rough. That's all sufficient for this one. I will go to next part now. Now we will start one by one type of support which you require for beam problem or structural engineering. First, simple support. You should make a note. See, I am dictating. Simple support means this way. Some member is just resting on that one. This can be a wall. It can't be a column, because if it is RCC column, it becomes rigid joint. It can be a steel column where a plate is provided, some member is resting. There is no connection between these two. It is not monolithic, see, like this. Now, if you apply a loading this way, it cannot move vertically. So, you should write here. What all I am dictating? Vertical displacement is prevented completely. Therefore, there will be vertical reaction. If you call A, say VA. I will call VA. But if you apply a load this way, see, if you apply a load this way, it will move. Therefore, there is no reaction horizontally here. Okay. I will give summary in the next class. Roller support. See, something like this. We won't discuss more about roller support now. See, roller support. See here, sufficient, 2 pens sufficient. Okay, shall I have one more pen? Not required. See, roller support. If you see roller support right here, roller support, you can make a note here. Plane of roller is horizontal. Plane of roller is vertical. You should write. Roller plane is horizontal, roller plane is vertical, roller plane is inclined. See, I told you, those who are serious should write. Now, this is the case of roller in horizontal plane. See, now, if I apply a vertical load this way, see, it will prevent it. Vertical displacement is not allowed. See, I will do one thing now to understand here. Displacement delta I will write here. See, delta vertical is 0. Delta displacement horizontal is there. Right means it is allowed, is there. Therefore, vertical reaction. See here. Here, displacement in vertical direction is 0. Therefore, there will be reaction RA equal to RA reaction, but vertical, therefore VA. See, reaction is normal or perpendicular to plane of roller. So this RA I can call VA. And displacement in horizontal direction is not 0. It is allowed. See here. It can move. So no reaction this way. Now consider roller in vertical plane. See here. Vertical plane. Now, if you apply load this way, reaction will come. So here, displacement in horizontal direction equal to 0, but displacement in vertical direction is allowed. See, this will prevent horizontal displacement. So there will be a reaction RA which is HA. Again, reaction is perpendicular to plane of roller. RA is HA, but no reaction this way. See here. Now, suppose it is inclined plane. See here, inclined plane. Inclined. If you apply perpendicular to the plane, it will be stable. See here. Therefore, there is displacement is 0 perpendicular to plane. Perpendicular to plane. Therefore, reaction is once again perpendicular to plane of roller. Now I will call RA. It is neither horizontal nor vertical. So RA. This R is vertical. This R is horizontal. This R is R. But displacement is allowed along the plane. Along the plane. It is not 0. It can move this way. So no reaction this way. Or remember, simple support. Next class, full board I will give statement. See, simple support, vertical reaction, and full roller support, only one reaction which is perpendicular to plane of roller, that is this way. More explanation I will give next class. Now, I am going to conclude the class by considering two more support. One of them is called hinged support, other is fixed support. I will tell that much and close, because this class is introduction class. Tomorrow title will be, next class, different types of supports and how the reactions will be there. Then equilibrium equations, then non-stop problems, marathon problems. The last part pending is hinge and fixed. I will explain. Now consider next support, hinged or pinned support. See, something like this. This all I will explain later. Right now, introduction. See, or you take a member and put a pin. See, you take a pin here. Now, if you try to move horizontally, it cannot move. If you move vertically, it cannot move. But if you try to rotate, it will rotate. Best example is door hinge. See, there's a door is there. If you try to pull the door horizontally, door will not move. If you press the door vertically down, door will not move. But if you apply a force this way to create a couple moment, door will rotate. If door is not rotating, the very purpose of door is lost. So we can give lot of example for pin support. See, even for example, see, our hand, this junction is pin support. See, pin support. See here, it can rotate, but it cannot move horizontally. This movement is something else. Don't worry. If I firmly fix here, see, if I apply vertical load, see, it will rotate. But if I press down, it will not rotate. If I pull, it will not move. So, hinged or pinned support, say A, you should write displacement in vertical direction 0. It cannot move vertically. Displacement in horizontal direction 0. It cannot move horizontally, but rotation is allowed. Therefore, two reactions, vertical reaction and horizontal reaction, say VA and HA. Vertical reaction I will call VA, say VA, horizontal reaction say HA, but moment reaction is not there. MA is 0. Okay, now fixed support. See here. This way. Apply horizontal load, it cannot move. So therefore, horizontal displacement equal to 0. Apply a vertical load, it cannot move. Vertical displacement 0. Try to rotate? No. See, if you try to rotate, support will give you reacting moment. Or here, vertical displacement is prevented, therefore there will be vertical reaction. There will be vertical reaction, VA. Horizontal displacement is prevented, therefore horizontal reaction, HA. And rotation also prevented. When rotation is prevented, you know, when you try to rotate, you can prevent it by applying a couple only. So, reacting moment, say MA. Remember now, this right side, left side, upward, downward, anti-clockwise, clockwise, all will come later. Right now, I want what? Simple support. I never told upward, downward. Vertical reaction. Roller, perpendicular to the plane. Hinge, vertical reaction and horizontal reaction. Fixed support, vertical reaction, horizontal reaction and reacting moment. Okay, now what I will do in the next class is full board. I will write one by one support with a lot of information that you have to take a screenshot and maintain for rest of your study. I will explain each and everything, and then I will tell about determinate and indeterminate structure briefly. Furthermore comes later in structural analysis, not now. Right now, briefly, what is statically determinate structure, what is statically indeterminate structure, what are the basic conditions of static equilibrium, that already over. Remember, that's why I told you have to go through each and every class. Basic conditions of static equilibrium, I thoroughly explained earlier. And one note, remember, these are all for coplanar force system, not three-dimensional. If it is three-dimensional, there will be three reactions here. One reaction in Z direction, there will be 6 reactions here. Vertical reaction, this way horizontal reaction, this way horizontal reaction, one moment like this, one moment like this, and one moment like this. Our discussion is only for coplanar force system. Remember, someone will tell there are 6 reactions. I will tell I know it. But engineering mechanics point of view, you require this much. Those extra information will be given when you require it, not now. In the software class, I will explain all those things. When I take software class, software will always give 6 reactions. Therefore, at that time I will explain. Right now for engineering mechanics, simple support, just vertical reaction, comma, roller support, reaction is perpendicular to plane of the roller, hinged support, vertical reaction and horizontal reaction, fixed support, vertical reaction, horizontal reaction and also reacting moment. I will conclude today. Next class I will continue and give full explanation once again that is required for solving problems later. Okay, thank you.